The current I through a resistor is measured with a digital ammeter to be 0.10 amps. The uncertainty in the calculated value of I squared will be. To find the uncertainty in I squared, we need the uncertainty in I firstly, and how to find it? There is the next rule. If we use a digital device, the absolute uncertainty is equal to the smallest increment. And here, since it's a digital ammeter, since it is measured correct to the hundredths, the absolute uncertainty in current is just 1/100th amps. And if we use an analog device, the absolute uncertainty will be half the smallest increment. For example, if you use such a ruler, centimeters, half the smallest increment, you can see that it's 0.5 centimeters, so it will be plus minus 0.5 centimeters. And for example, such a reading, it must be 2/10, because absolute uncertainty and value must be to the same number of decimal places, or must be to the same digit of a whole number. So we round this value to 0.5 or to 3 or to 4. So we can see that it's the closest value is 3.5, so it will be 3.5 plus minus 0.5. Or if it looks like this, it will be 3.0 plus minus 0.5. And if it looks like this, it will be 4.0 plus minus 0.5 centimeters. So the absolute uncertainty in the current is 0.01 amps. And how to find the uncertainty in I squared? There is the next formula in data booklet, that if y is a to the power of n, relative uncertainty in y is equal to the absolute value of n multiplied by the relative uncertainty in a. Notice that the rule is for relative or fractional percentage uncertainty. And if question is to find the absolute uncertainty, you cannot find the absolute uncertainty directly. You need to find the relative uncertainty firstly, and then calculate the absolute uncertainty. So the relative uncertainty in I squared, delta I squared divided by the value, which is I squared, is, according to this rule, it's 2, because I squared, multiplied by the relative uncertainty in current, so multiplied by delta I over I. And it is equal to 2 delta I 0.01 divided by I, which is 0.10, and it becomes 2 multiplied by just multiply by 10 numerator and denominator, so it multiplied by 0.1, so it becomes 0.2. Or if we multiply by 100%, it's 20%. And we can see, actually percentage uncertainty required, so it's 20%, and it's the required answer. And if question is to find the absolute uncertainty, we can see directly from this formula that the absolute uncertainty in I squared, it's 0.2 multiplied by I squared, which is 0.2 multiplied by 0.1, so value squared, and you just calculate it. And it becomes 0.2 multiplied by 0.01, so which is 0.002. And how to write the answer for calculated value? I squared, it's 0.01, just 0.1 squared, plus minus the absolute uncertainty 0.002. But if you leave like this, it will be not correct, it will be a mistake. The answer and the absolute uncertainty must be to the same number of decimal places, or value must be rounded to the same digit if it's a whole number, so it must be written like this, to 3 decimal places, and it's correct, amps squared. Or if we need the absolute uncertainty in I squared, we can simplify here, because finally we need delta I squared, so we can see that it's 2 delta I divided by I, but then we need multiplied by I squared, so we can write that it becomes multiplied by I squared, and simplify it, 2 delta I multiplied by I, and it becomes 2 delta I is 0.01 multiplied by I, which is 0.1, and it becomes 0.001 multiplied by 2 is 0.002 amps squared, and we can see that we get the same result. And that's all for this question.